Hello and welcome to Cognito Key. Today, we're going to pull back the curtain on the invisible magic that makes our computers so incredibly fast. We're going to figure out how they juggle massive amounts of data so efficiently, all without, breaking a sweat.
I mean, it's pretty amazing when you think about it, isn't it? This kind of multitasking seems almost impossible. Well, the secret lies in solving a really big problem, a fundamental bottleneck deep inside your computer's design. A problem that all revolves around one very, very busy component.
Okay, so let's get into it. The best way to picture your computer's central processing unit, or CPU, is to think of it as a brilliant but completely overworked manager. It's the brain, right? It handles all the important thinking. But what happens when that brilliant manager gets bogged down with simple, boring tasks, like moving boxes or, in this case, data from one warehouse to another? Well, back in the day, there were two main ways to handle these data transfers, and honestly, both were pretty terrible. The first way, programmed I/O, is like our managers stopping everything they're doing just to stand there and watch the data transfer one byte at a time. Yeah, the job gets done, but all the real work comes to a complete standstill. The other method, interrupt-driven I/O, is a little better, but it's like someone constantly tapping the manager on the shoulder, interrupting their big project just to say, hey, one more byte is ready. It's just so inefficient.
So you can see the problem, right? With both of these older methods, the super smart CPU is stuck doing basic grunt work. When you're trying to move large files, this creates a huge bottleneck that would make modern computing just impossible. Clearly, there had to be a better way.
And here it is. This is the hero of our story, direct memory access, or DMA. The absolute best way to think about DMA is as a super efficient assistant. This assistant is hired specifically to take over all those boring data-moving tasks, which frees up our CPU manager to focus on what it does best, thinking.
And if we look at the official definition, it backs up our story perfectly. Direct memory access lets devices, like your graphics card or hard drive, talk directly to the main memory, completely bypassing the CPU. In our little analogy, this means the manager doesn't even have to be in the room for the boxes to get moved. At its core, it's really just a simple act of delegation. The CPU just gives up control of the system's main highway, that's the system bus, for just a few moments. This simple handover to a specialized piece of hardware, the DMA controller, completely changes the game. But wait, how does this handover actually happen? It's not chaotic. It's a very clear, very professional four-step conversation, kind of like a secret handshake between the components to make sure the whole process is smooth. Okay, so this handshake happens in 4 super quick steps. First, a device, maybe your network card, sends a request to the DMA assistant. The DMA then politely asks the CPU manager to please hold and free up that system bus. The CPU says, sure, no problem, and sends back an acknowledgement. Finally, the DMA tells the network card, okay, the coast is clear, the bus is all yours. It's just a really beautiful and efficient little dance. Now, our DMA assistant is pretty clever. It doesn't just have one way of doing things. It actually has 3 different strategies it can use, depending on how urgent the task is and how busy the CPU manager is at that moment. These 3 strategies really show you how smart DMI is. In burst mode, it grabs the bus and says, I need to move this whole giant file right now. For more balanced work, it uses cycle stealing, where it just steals the bus for a tiny moment at a time. And then there's transparent mode, which is super sneaky. It only works when the CPU isn't using the bus anyway, so the CPU doesn't even notice. 0 delays. So after all this clever coordination and all these different strategies, what's the bottom line? Let's talk about the huge benefits and, the small trade-offs of using this incredible system. The advantages are just massive. First off, speed. Data transfers get so much faster. Second, efficiency. You're wasting way fewer clock cycles. But the most important thing is that it completely reduces the overhead on the CPU. Our manager is finally free from all that boring admin work and can focus on actually running your games and your apps, which is exactly what we want it to be doing. Of course, nothing's perfect. Having a dedicated DMA controller is an extra piece of hardware, so it adds a little bit to the cost. And it does make things a bit more complex. For example, it can cause something called cache coherence problems. That's kind of like the manager looking at an old version of a file because the assistant updated the main copy without telling them. But for modern computers, these are trade-offs that are absolutely worth making.
So the next time you're downloading a massive file while playing a game online and listening to music all at the same time, just take a second to appreciate the silent, brilliant work of the DMA controller. It truly is the invisible engine that makes all of our modern multitasking possible.
If you enjoyed this deep dive, please subscribe to Cognito Key for more explainers on the tech that shapes our world. Liking and sharing this really helps our channel grow, and we would appreciate it so much. Thanks for watching.